Let's begin by talking about what 3D models are and some of the different types of models that you may come across. So when we talk about 3D models and modeling, basically what we're talking about is all of the stuff in your scene or in your game, all of the things. So typically in a film or in a game, that's going to be your characters, your props, and your environments. So for instance, in a game, the character that's running around is going to be a 3D model. The gun that he's holding is going to be another 3D model. And the streets that he's running along or the building that he's climbing through, those are all going to be 3D models that are built and then integrated into that game engine, or in the case of film, rendered out as an image. Okay, so basically anything tangible. You will also have things like clouds of dust, things like that. Those are going to be more effects. And so anything, any objects basically in your scene are going to be 3D models. And 3D models are, you can see here in Maya, we have these models. We can kind of rotate around these. You can see all sides, and these are kind of the most basic shapes that we have available to us. We've got a sphere, cube, and a cylinder, and these shapes are kind of a basic building blocks of the more complex models that we're going to be creating. So if you go through and create a model, a lot of times you'll start with something as simple as this, even though the end result will be much more complex. Now, no matter what shape that we're trying to get, there are three basic ways that we can get to that shape. And these are called types of geometry. So you hear that term geometry, we're just talking about the model itself, the pieces that make up the model when you hear that term geometry. And so there are kind of three basic ways that we can create this geometry. These are polygons. And so we'll talk a little bit more in depth about what all the components of a polygon. But you can see some of the things to look at for polygons are the fact that they've got these really sharp edges. Okay, and here if you go on the side, you can see that even though this is a sphere, you can see these facets or these points. Okay, because of the number of lines here, edges these are called. On this cube, you can see that it's very, very sharp here on the edges. Now the polygons are going to be your most basic type of geometry that you're going to be working with when you model. Now you'll notice you're not getting anything very smooth. So if you wanted to get something very smooth, you could use something called NURBS geometry. That's NURBS, non-uniform rational B-spline geometry. And there are a few key differences to NURBS geometry, and we'll talk about those a little bit later, but you can see one of the big differences visually is the fact that it's very smooth. Okay, the sphere especially, and also the cylinder. If we look at the top of the cylinder, you can see the facets there versus something that's very smooth here, even though we don't have a lot of lines defining that. Now the NURBS geometry is going to be defined a little bit more by mathematical formula rather than explicit x, y, and z coordinates of these points. So explicitly stating where's this point in 3D space versus this surface is calculated a little bit more mathematically. So you get a nice smooth curve that you can really get up close on, and it's still going to be smooth when you render that out. Okay, so NURBS typically are going to be maybe a little bit more difficult to deal with when you're building complex models. A lot of times they may be used for sometimes mechanical pieces. Sometimes they're used for characters in specific applications, and some studios use those. Typically your polygons are going to be a lot more prevalent than your NURBS, but there are definitely applications that the NURBS work really well for. Now we've got the kind of the sharpness and the flexibility of the polygon, and then we've got the smoothness of the NURBS. A third type of geometry, and something that's going to be used really widely, is the subdivision surface, or sub-D you might hear. And so subdivision surface is really based on the polygon, and it's taking that polygon. If we smooth this very quickly, smooth the display, you can see that we actually get something very smooth, much like the NURBS, but we're dealing with something that is very akin to the polygon surface. So we're able to use a lot of the tools that we use on our polygons on these subdivision surfaces, but we also have the ability to make those nice and smooth like some of these NURBS surfaces. Now, subdivision surfaces, you may hear a term Catmull-Clark or some of the other names associated with the subdivision surface. Those are referring to the specific subdivision algorithm or how that subdivision surface is calculated. So it's taking that sort of polygon cage and repeatedly subdividing that based on a particular equation, basically, to get the result. And there are different types of equations, and so you may hear names like that. That's what those are referring to, is the type of smoothing algorithm or subdivision algorithm that it's using. Okay, so where can we find these models here in Maya? So we've got them in the viewport. There's information that we can gather about our model. For instance, if I select this model here, you can see my transform values over here in the channel box. Okay, because it's a subdivision surface, we also have some information about that. We'll talk about it a little bit later. If we have any history on that, if we've done any used any tools on it, those will appear over here. Okay, if we'd like to find out some information about more information about this, we can go to the attribute editor, hitting Control A, and you can see that there is information about the render stats, things like that. There's transform attributes, a lot of information about the display and so forth. So some basic information can be found in the attribute editor for each of these models that we create here in our viewport. You can see that we can select these and that changes in our attribute editor. Now we can also find these in Maya. Everything is basically a node, and so to find the nodes here and start to parent things together, and we'll talk about that a little bit later, but to see this we can go up to Window and go to Hypergraph, and you can see that all of these objects are associated with a node. And so you won't really need to know too much about the nodes themselves until you start kind of parenting and grouping everything together. And then you want to be able to organize your model, and you'll do that either in this hypergraph here with these nodes, or we can also go into the outliner, and you can see we have a visual representation of the different types of geometry. So you can see all of these are NURBS. Okay, and you can see here, if we look at this, one of the aspects of NURBS is the fact that our cube is actually 6 sides rather than one piece. Okay, and you can see the icon here. These sub-Ds have a different icon and a different naming convention. We can go ahead and name, if we double click on this, we can name these something else. So that makes a little bit more sense. They all come in with kind of the default names. And then we've got our polygons with their own type of a icon right here. Okay, so this allows us to come in and start to parent these together, group these together, and organize our scene, because we only have 9 models in here, but you can see we've already got a ton of nodes starting to pile up. Now you can imagine if you start to get a really complex scene, you can imagine how the outliner or how the hypergraph would look with all of those nodes, and so it's really important to stay organized when you're working with your models. Okay, so now that we've talked a little bit about the basics of what models are and the different types of geometry, let's go ahead in the next lesson and look at how we can start to create models, different ways of creating those and importing, exporting those, and then we'll move on to looking at the display of our models, transforming our models, and then get into a little bit deeper with the actual pieces that make up these different types of geometry. So we'll go ahead and continue on in the next lesson.